So we will focus on algebra only. If you guys have other topics that maybe you want to go over, that we will leave around like 15-20 minutes in the end, and we can discuss those topics as well, if there are any particular topics. All right, so that's the syllabus code, then the grading scale is different. So in Edexcel, you are graded from 9 to 1, and in IGCSE, you are graded from A star to G, which is basically the course code that you guys do in UAE or Qatar both. Then curriculum structure, it is single tiered in Edexcel, which means that you can select from either a higher level math or a foundation level math. Higher level is just more advanced version. You'll have a couple of new topics and additional topics. So there are topics that are both in foundation and higher, but you'll have more in higher. And then your Cambridge one is a dual tier syllabus, in which you can do core and extended, or you can just do core. It's called dual tier because if you are doing extended, you have to do core as well. The number of papers is the same for both. There are 2 papers in IGCSE Mathematics, and there are 2 papers for IGCSE Mathematics Cambridge. But if you do both for Cambridge, core and extended, then you'll be giving 4 papers for Cambridge IGCSE Maths. For topics covered, we'll go over them when we are doing the course outlines. Assessment style is mostly the same. There are so in Edexcel, there are smaller questions are more in Edexcel as compared to your Cambridge. In Cambridge, you are assessed more on your word problems and your application-based questions. Again, as mentioned earlier, since Edexcel is new, it is internationally accepted. But if you are targeting universities that are first year or second tier universities, then taking Cambridge board is more feasible, as it is more globally recognized in comparison to Edexcel. Then again, both of them lead to A levels. However, if any of you is looking to continue their education in ACCA or CA, you can immediately do CA or ACCA after doing your O levels or your IGCSEs with either board. It's better that you do it with Cambridge if you are not opting to do A levels. And then, yeah, so exam duration is around 1 to 2 hours. And for either of the 2 boards. If you guys have any questions regarding these IGCSEs, you can ask in the chat and I'll get back. And then you have O-levels. So for Edexcel O-levels, there is not much of a difference. Almost all of it is same, just that O-level is more rigorous when it comes to even when it comes to any kind of exam. And in O-level Edexcel, you wouldn't have a foundation tier, you will just have a higher tier. You do have foundation tier, but in that, most of the topics from higher tier are also included. And when you go for higher tier, it is more sort of an additional math sort of thing. So if you want to do your career in math, only then people opt for O-levels mathematics in Edexcel. For O-levels, there is one major difference. For Cambridge O-levels, there is just one major difference, that you have your grading scale as A star to E and not A star to G. So so the likeliness of one not being able to pass Cambridge O-levels, they go for Cambridge IGCSEs because the grades are till G, and and according to the threshold, usually G is on either 18% or 15 to 20%, basically. So there's very less likeliness of failing. Um, then in O levels, Cambridge, there is one paper that is calculator based and another paper that is non-calculator based. Again, in IGCSE Cambridge, there is no such restriction, but in O levels, there is. And then the paper style and the paper duration also is different in O levels in Cambridge by one hour or 0.5 hours. The rest of it is just all the same for both of these courses. Again, if you have any questions regarding the boards, you can ask. Otherwise, we'll just move ahead. All right, then there are course outlines. We'll just quickly go over them and see what topics they cover. And so this is what the course outline looks like for Edexcel. So these are the contents. We'll primarily just focus on the content bit, but they do give you information on the assessments, how they will be, what are the objectives, what kind of questions appear, are you allowed to use a calculator or not, all of that kind of information you can find here. And then if you want any other information regarding the administration and any other thing, that is also in your course outline. So right now, let's just go to page number 7 and talk about foundation tier. Okay, so foundation tier would cover topics that are your number and your number system, equations, formulas, and identities, sequence, functions, and graphs. Then we have geometry and trigonometry, vectors and transformation, geometry, statistics, and probability. You'll see that the topics are same in higher tier as well, but when we go to the subtopics, that is where the difference is. So these are the topics for your foundation tiers. You have integers, then you have fractions, and then multiple things in fractions. And then we have decimals, powers and roots, sets, language and notations, percentages, ratios and proportion, degree of accuracy, standard forms, applying number, and electronic calculators. Then in the second bit of it, equation formulas, there's use of symbols, there's algebraic manipulation, there are formulas and expressions, linear equations, proportions, simultaneous equation. Most of these we'll be covering today, hopefully. And then we have quadratics, we have inequalities, and then as we go on, we have sequence, and then we have like multiple subtopics. See, now here, calculus is only part of higher tier. So if you are opting for foundation tier, you wouldn't have to do calculus. Then we have geometry. Again, there are multiple subtopics. Some of it are just going to be for higher tier. Others are going to be for both foundation and higher tiers. Again, same, we have vectors, we have transformation, geometry. Then we have statistics and probability, in which we do graphical representation, statistical measures, probability. Yes. And similarly for foundation tier, these are the additional topics that you have to do more than the foundation tier. So in decimals, you have one additional topic. In power and roots, you have 3 additional topics. And then So all of these you'll have to do in higher tier math. There's proportion, there are more topics in proportion, there are more topic in simultaneous equations, quadratics, inequality. The topics are the same, just the subtopics are more in higher tier as in comparison to foundation tier. So if any of you is looking forward to do maybe economics or accounts or engineering in your universities as your undergrad, then I think higher tier would be the choice to go. And then similar topics are in Edexcel as well. Oh, sorry, in Cambridge as well. Let's just quickly go to the syllabus content, which is on page number 12. So you have numbers, just like in Edexcel. We have orderings, the four operations, indices, standard forms, estimation. And there are some topics that are additional in this. For example, estimation wasn't part of your Edexcel syllabus. And there are rates, percentages, using a calculator, time, money, exponential growth and decay. These topics are also in Edexcel, but they don't have like explicit names in them. They are the subtopics of the already mentioned topics. Then we have algebra and we have graphs. These are similar to what there is in Edexcel. Then inequalities, frequent. So basically, the content is not very different, just the things that were discussed when we were looking at the different kinds of boards, only those are different. So now it's up to you, whichever a board you want to go ahead with. How many of you are just starting your O levels, and how many of you are already into your studies and are preparing for your exams soon? You can just type it in the chat. Okay, I see one of you are taking your exam this Thursday. Okay. What about the rest of you? All right, so all of you are taking your exams soon, like this Thursday. I see. So, sure. Then I think you must be familiar with whatever I've told right now. What are your boards? Is it Excel or is it Cambridge? At Excel. Okay. Sure. Okay, all three of you are doing into Excel. Sure. All right, then I think then we should not go over the paper style, because I'm sure you've already went over it. If you guys want, then we can actually go over it. We can restructure our class today, because I thought that you guys are just joining your O levels or IGCSEs. So what we can do is that we can start with algebra right now, and then in the end we can do some past paper questions, so that may help you in your exam on Thursday. How does that sound? Okay, it's just three of you, so you can just unmute your mic and say something if you guys want.
Miss, can we go over sequences?
Over sequences, sure, we can do that. All right, what are you confused about in sequences? Do you want me to go over all of it?
Yes, please, just like the part that we have to form an equation and like the sum of the equation.
All right, sure. We can go with that. Just give me 1 minute. I'll open your course outline and I'll see it's included. So we'll do sequences and series instead of sequences. Okay. What is a sequence? Would anybody want to answer? How do we define a sequence?
It's numbers going up and down by a specific rate, specific amount.
Yes, so a list of terms is defined as a sequence. As a So if it is 3, 6, 9, 12, 15, 18, we define it as a sequence because it's a list of terms and then a similar, they're increasing at a similar rate. So there's an addition of 3 in each. It is called an increasing sequence if the other terms are increasing. It is called a decreasing sequence if each new term is a smaller number than the previous term. And it could also be a periodic sequence, which means that you'll have, let's say, -2, then you have 4, then again you have -2, then you have 4, -2, and 4. After a certain number of terms, your sequence repeat itself. So that's called a periodic sequence. Then we have arithmetic sequences. Arithmetic sequences are basically defined as,
What is the -2, 4, -2 called again?
it's called a periodic sequence. Periodic sequence. Periodic means period repetition. So if there is any sequence, a sequence maybe that says 3, 9, 18, 3, 9, 18, 3, 9, 18. So whenever there is a repetition, we call it a periodic sequence. Let's talk about arithmetic. Arithmetic, the general sequence looks like this. plus 3D, and then so on and so forth. A is your initial term. D is your difference. And then this is n plus 1. N plus 1. So in arithmetic, what you essentially do is that there is an initial term, and with whatever new term you want to add, you put that initial term and then you add the difference into it. So if, for example, I have A as 2, and you know that D is, let's say, 4. So the second term is going to be 2 plus 1 into 4. Third term is going to be 2 plus 2 into 4. Fourth term is going to be 2 into 3. 2 plus 2 is 3 into 4. It's going to be 2, 6, 10, and then it's going to be 14, and so on and so forth. So when you talk about the submission or an arithmetic series, okay, what is the difference between an arithmetic sequence and an arithmetic series? Anyone who knows the difference between sequence and series? Okay, I see one no. Anybody else? Also, for the people who just joined, are you guys giving your exams soon, or are you just starting your O levels? I think Rehan has recently joined. So Rehan, are you just starting your O levels, or are you giving your exam on Thursday or anytime soon?
I'm giving my exams this on the.
And your board is also at Excel?
Yeah.
All right, sure. So the difference between a series and a sequence is that a sequence means that you are writing individual terms. A series means that you are summing those individual terms. By submission, it means that you're adding up all the terms that are in the sequence. So a series would, it may look like this to, so this is a sequence 2, 6, 10, 12, and so forth. A series would look like this, a formula. So a series would mostly give you only one term answer because it is a submission of all the terms of a sequence. This is the formula that you use to find the sum or the series of an arithmetic uh, uh, sequence. Now, if we find a series for this arithmetic sequence that we have written, then that is going to be our n. Let's say our n is 10. N would be defined for you in the question. And D, probably either it would be defined or you would be given a sequence. And then you can see what is the difference between the first term and the second term, the third term and the second term, and you'll get the D. And at times when you're not given the N and you're just given the sequence, if there are no dots that are preceding the last term, it means that this is where the sequence ends. So the N is going to be the number of terms in the sequence. Right now, in this example, we are assuming that our N is 10. So we would do 10 divided by N, divided by 2, into 2 times A again, the initial term, which is 2. We add it to N minus 1, which is 10 minus 1. And our difference is 4, I think. Yeah. Our difference is 4. Can one of you calculate and tell me what the answer is?
It's 200.
So the answer you get is 200. Did somebody else get the answer is 200? It's gonna be 9 into 4. I need to verify the answer. Can somebody else also tell if they got the same answer? Okay, I think so this is the correct answer. So a series answer would always look like this. So for arithmetic, this is the formula that you'll use. So if there is any arithmetic equation at all, you will be, yes, exactly. Sequence is
That's because A,
list
if it is
of
any
numbers.
constant number, it's 2, 3, 4. When you put it any number to the power 0, any number to the power 0 will always give you 1, right? So if A is any number and you're putting it to the power 0 because F is 0 over there, so that's why you always get the answer 1.
Yes, who was it?
So X is always 0.
What was the question? X is always 0. Is that the question?
No, miss, by accident, my voice is open.
I cannot hear you properly.
By accident, I was talking about something else.
Okay. Sure. Is this clear to all of you?
Yes.
Okay. Are you guys foundation level maths or higher tier math? Okay, all of you are higher. Sure. So I think proofs are included in your in your syllabus. So let's do the proof of Sn and over to so the proof for this is that we will just write. So we'll start by writing the general term, which is plus a plus d plus a plus 2d plus a plus n minus 2d plus a plus n minus 1d. We have n minus 1 because this is the first term, this is the second term, this is the third term. So we have 2 here, which means that it's n minus 1. So over here, I think I wrote n plus 1. This is supposed to be n minus 1. The first step is that you write the general term. If this is confusing you guys, so there's no need to write this. This just essentially means that we always end on n, and whatever n we have, it would be the term you multiply with d would always be n minus 1. So that's why we have n minus 1 in the last term. In the second last term, we have n minus 2 because this is the second last term, and we'll have to subtract 2 from n in order to get the number we multiply with the difference. So if this is confusing you guys, it's okay if you don't write it in the proof. You can just write.
The sum of sequences is like all of the numbers from 1 to 10 added together from the sequence.
Yes, 1 to whatever number it is, you add them all together and you get the sum.
Okay.
It could be 1 to 10, it could be 3, 7, 12, 14, 28. It could be any numbers. If you're given a sequence and you are asked to write its series or to give the sum of it, you just add them all up. And that will give you the answer. Now, this is going to be your first step. Your second step is going to be that you write all of this in reverse because it's addition. Whatever way you write it, it's going to give you the same answer. So you write it in reverse. You write a plus n minus 1d plus a plus n minus 2d plus dot plus plus d plus a. Now, in third step, you add, let's call it 2, let's call it 1. You add Sn1 with Sn2. Now, when you add it, it would become 2 times Sn. And this would become when you add both of these up, it would become n times 2a plus n minus 1d. When you add both of these up, this is the answer that you would get after simplifying and after doing all that bit, you'll get this as the answer. And then since you have to write Sn, so you bring this 2 to the other side, it becomes n over 2, 2a plus n minus 1 d. So this is the proof of this formula. And here it is proved. So proofs are usually very less part of your exam. Maybe only 3% or 4% of your exam would depend on this. Or maybe you wouldn't get any at all. But since this is part of it, and it's very hard to understand a proof, because when you go to your undergrad and do your maths there, you'll know the different types of proof that exist, induction and all of other sorts of them. Then making sense of these proofs are very easy, but at your stage, because you are not introduced to those techniques, it's hard to make sense of this. So the only way to remember a proof is just to learn it by heart, because there are multiple that would come for in your in all the topics that you covered in your syllabus. So if you guys have any questions from this, you can ask, otherwise we'll just go ahead.
Miss, can you explain it again?
The proof bit?
Yeah.
Sure. So the first step in this was to write the general term for your arithmetic sequence. When you write the general term, which is this, you add this in the end, because this is always going to be the last term. Even if your n is just 3, this is going to be the defining factor. So you write this in the end. In the next step, you just reverse the entire thing. By reverse, I mean whatever you've written in the last, you write it in the first, and whatever you've written in the first, you write it in the last. That's the second step. And the third step, the two equations that you have now, you add them both up, and then you solve it, you simplify it, and then you solve it for Sn. When you solve it for Sn, you'll get the answer. So there are 3 steps, actually 4 or 5 steps. I'll write down those steps, so you guys can maybe just know that. Step 1 is the general term for an arithmetic sequence. Second is that you reverse the entire sequence. Third is you add both equations. Fourth is you simplify. Fifth is solve it for Sn. So you follow these 5 steps and you will get to the proof of it. Make sense?
So do we just memorize this or like?
Yes, you'll have to memorize this. So the proofs, it's a suggestion that memorize the proofs, because there is no other way to remember it. They can give you, I mean, because at your level, they'll just give you the proofs you have done. So it's better you just remember and memorize the proofs that you have. I think in total, there are around like 10 to 12 proofs in your syllabus. So just memorize them.
Miss, can you please do another example?
Okay, so proof cannot have another example, because proof is a proof of a formula. So it's just one way of doing it.
I mean, can you do like another example of a question that involves proof?
Okay, so another question cannot involve the proof, because proof is just one very particular thing that only happens through one form. And we can do another question of arithmetic series, but proof is only this. Proof is not in another question. Proof cannot join another question. However, yes, there could be questions like this that you are given an arithmetic sequence. In the first part of that question, they ask you to maybe write the first 10 terms of the arithmetic sequence. Then in the second part, they ask you to prove the arithmetic series formula, which is this, which is just, you'll remember this and you'll write this exactly. And then in the third part, they'll just say, using the formula that you have proved, calculate the series or the sum of the first 100 terms of the arithmetic sequence. So this is how it could be part of a question, but it could not be the case that only one part has something that involves a proof in it. So proof is just very it's very seculated from the other bits of the practical implementation of the formula itself. So we can do another formula question and then we can jump back to this towards the end of the classes so you guys remember it. Does that sound good?
Miss, what about the proof of an odd number or like an even number?
Oh, that's the periodic function. We'll get to that. But the proof of periodic function is not, a periodic series is not included in your syllabus. Only arithmetic is included.
But I saw in a syllabus, like not in the syllabus, like in a past paper. Like proof,
Geo,
like 20 something in a is a odd number.
odd numbers,
Yeah, yeah, yeah. Prove that a
like,
number, like some number is an odd number. Like the
oh, that's not related to sequence and series. That's related to numbers. We can discuss numbers later in the class.
okay, okay, okay.
Yeah. So what you have said, the proof that this number is an odd number, whatever number it was, you use this formula to prove that 2n minus 1 or 2n plus 1. Because whatever you multiply with 2 would always give you a positive or an even number. So whenever you subtract 1 from an even number, you add 1 to an even number, you would always get an odd number. So when we discuss numbers, we'll go into the detail of this proof as well. All right, I'm gonna write in a question here and I want all of you to give it a try. And I'll give you guys 5 minutes. And after that, all of you send me your answers in the private chat. So I know that all of you have solved it. Okay, so the question is, oops. So
Miss, is this 2,225?
yes, that's 2,225. Okay, this is the question. All of you have 10 minutes to do this. It's 12:54 at 1:04. I'll ask you guys to send it to me in private chat, whatever answer you've gotten. And then we'll see if we have to do it together or did you guys get the answer yourself?
Miss, is N 25?
25. Yes, it is 25. Did somebody else get this?
Can you
Sorry?
still go through it? I want to make sure my working out is correct, like throughout.
Sure, you can send it to me. You can send it to me on the chat. Send me on the private chat. I want everybody else to give it a try as well, because you guys have your exams so near. Or you can send it to me on WhatsApp. My number is in the group. For the second part, yes, you can get the answer just by putting it in the calculator. For the first part, you cannot. So in this question, this is an 8-mark question, and finding the value of n is only for 2 marks. The rest of the 6 has to show that you get 7n squared plus 3n minus 4450. So if you just put it in the calculator, you only get 2 marks. So I want you guys to give me 3 things. You need to tell me what A is, what D is, and what N is. So 3 things: A, D, and N. So whoever told me the answer for N, please tell me the answer for A and D as well.
Miss, the answer for A is 7, and then B is 3.
7 and 3.
And then
So
25 for N.
So answers for A and D, can you see? I am afraid they're incorrect for A and D. For N, it's correct. For A and D, it's not. So your A is 7 and your D is 3, right?
Yeah.
Yeah, so these are incorrect. But N is correct. There are 5 other people in the meeting. I want everybody to send in their answers.
Miss, is A 5 and B 7?
Yes, that's correct. That's correct. Good job. All right, the rest of you. Okay, so yes, I don't understand. Sure. I'm assuming the other 2 people also weren't able to solve it. So we can go over it together. Okay. So first, always write down the information that you're given in the question. It makes life so much easier. So they have given you that the 5th term of an arithmetic series is 33. So S5 is 33. And then they say that the 10th term is 68. S10 is 68. We know that S5 is A plus 4D and S10 is A plus 9D. How do we know that? We know it from the general term that we defined in the beginning. Now we
Miss,
say
I did the 68 minus 33, and then I divided that by 5. And no, like 10 minus 5 is 5. So if you find the difference between the 10th term and the 5th term, you will have 5, and then I divided that by 5. So I got the difference as 7.
Yes, that's also a correct way of doing it. That's also a correct way of doing it. This is more systematic, and this is more sort of a way other students would understand, because this is something we have been doing since the start of the class. But whatever you did, that is also correct.
Okay.
Yeah. So
Miss,
then
I have a question.
yes,
Miss, are you gonna send these notes that you're writing right now in the group?
sure, I can share them. I'll share them.
Okay. Yeah.
Then what you do is that you know that the 5th term is 33. So you equate this to 33. And you equate the other one to 90 equals to 68. Now you solve this using simultaneous equations. How many of you are familiar with simultaneous equations? Very familiar. Okay. I'm assuming all of you are familiar because this is part of algebra. I make a few mistakes. Okay. All right. I'll just solve it in detail for you guys then. we'll use the substitution method. By substitution method, we'll make A the subject of the formula in the first one. A subject in 1. This is 1. And this is 2.
Is it gonna be 4b minus 33?
It's going to be 33 minus 40. A equals to 33 minus 4D because we were going to move 4D to the other side. And since now I know A, I'll put it in the second equation. So that is going to be 33 minus 4D plus 9D equals 68. It's going to be minus 4D plus 9D equals 68 minus 33. This is going to be 5D equals to 35. And then D is going to equal 35 divided by 5. It's going to be 7. So we got D as 7. And then we find A. We know that A is 33 minus 4D. So A equals to 33 minus 4 times 7. 4 times 7 is 28. And then the answer we get is 5. So now we have the answer for A, 5, and D, 7. Another thing that they have given you in the question is the sum of first n terms is 2225. We know that the submission formula is n by 2 A plus n minus 1 D. And we now know that the sum of first n terms is n by 2. A we know is 5. This is 2A. 5 times 2, n we don't know, and D we know is 7. We simplify this, we get n by 2 into 10 plus 7n minus 7. And we also know that this is equivalent to 2225. So we just put it next to this equals to.
Miss, we first remove the 2 and multiply it by 225.
Yes. 225 into 2 is equals to n times 3 plus 7n. When we multiply 2225 to 2, we get the answer as 4450, which is equals to 3n plus 7n square. And then we rearrange it. So it's going to be 7n square plus 3n minus 4450 equals to 0. And now since it is a quadratic formula, you can just simply put it into the calculator and you'll get 2 answers. You'll get one answer as 25 and you'll get another answer as negative 25.4. But we know that n cannot be negative because it is a term number, so it is supposed to be positive. So we say that n is equals to 25. Okay. Any questions?
No, Miss, clear.
All right. Good. So this question is for 8 marks. It's going to be for around 8 marks. 6 marks are to find your A and D, and 2 marks are to find your N. So till here, if you're able to solve till here, you get 6. If you are further able to solve this, you get 2. So in total, you get all the marks.
Miss, can you repeat?
The mark distribution?
No, after, did you say anything?
No, I didn't say anything. I was just telling the mark distribution. Yes, are we going to do trigonometry tomorrow? Sure, we can go over trigonometry after this if we have time left. All right, so this was for the first kind of sequence that exists, which is an arithmetic sequence. The other kind of sequence that you study is your geometric sequence. How many of you are familiar with geometric sequence? No idea. Okay, one of you doesn't know what that is. Anybody else? No, we haven't done that. Okay. In school. All right, you haven't done that in school. Sure. Are all of you guys from the same school and same class? Okay. Okay, sure. But it is part of your syllabus. So I'll just go over it then. So the general term for your geometric sequence look like this. AR square, AR cube, and so on and so forth. A again is your initial term. R is your ratio by which you multiply each term to get the next term. And then square is n plus 1. So if I write the general term for this is the general sequence. General sequence. The general term for this is A, R, n plus 1. So if you're given any term, if let's say the question says that S20 is 36, then you just use this term to find any, if you want to find A, if you want to find R, you use this term to find it. Yes, is anybody saying anything?
Miss, can you give us an example of it?
Yes, we are jumping to that. So an example would just simply be, let's say we have 4, 8, 12, 16, 20. This is a geometric sequence. Why? Because multiplying 4. All right. So let me tell you the difference between arithmetic and geometric. Arithmetic is addition or subtraction. Geometric is multiplication or division. So if you see this sequence here could be considered arithmetic because you're adding 4 to it, or could be considered geometric because you're multiplying. You're multiplying. This is the table of 4. So it could be considered either. So here, this is 4 into 1. This is 4 into 2. This is 4 into 3. This is 4 into 4. This is 4 into 5.
Miss, but the arithmetic is only considered arithmetic and not geometric.
All right, so arithmetic can be geometric as well, and the converse is also possible. In this
Miss,
scenario,
what would be the difference in the amount of marks for both?
for arithmetic and geometric,
Yeah, would it be the same steps as we're doing for arithmetic?
the same steps, that these are two different kind of sequences. They might carry same marks, they might not carry same marks. It depends on the level of difficulty each question has.
Okay, ma'am.
And the formulas are different as well. So see, the general term formula is also different, and when we talk about the submission, the formula is going to be different. So the steps are also going to be different. So yes, an arithmetic at sometimes could be a geometric sequence as well, sometimes. And same goes for geometric. Sometimes the geometric sequence could also be an arithmetic sequence. So it just depends on you. If you see that either of the formulas do apply to this particular sequence that they have given, it's up to you whichever one you want to use. Unless they have explicitly told in the question that this is a geometric sequence and this, whatever the question is. If they have not told that and you think this is an arithmetic as well, you can use whatever you want to use. Yes, so looking at this example, the best way of getting to the general term for a geometric sequence is that write this on the top. Whatever, if it's a multiplication, if it's a division, just write it on the top. All right, so here it's 4 times n, that is giving you each term. So n here is 1, n here is 2, this is n3, this is n4, this is n5. So you're multiplying 4 with n, and that is giving you the next term. So this is going to be a general term for this term, for this particular sequence.
Alright.
So this was just a small example and a very easy example of how you can find the general term. So basically, A is your initial term, as I've told you earlier. This you would know by the starting of the sequence that they've given. R is your ratio, which is that you take the term n, let's say k plus 1, divided by n k. So you take the second term and you divide it by the first term. K is just simply the number of terms there are. So let's say you wanna find the ratio and you're given 10 terms. You can choose any term, let's say 7th. So that would be n7 plus 1 divided by n 7. So this would be n8 divided by n7, which is that the term that is the 8th term, you divide it by the 7th term in order to get the ratio. And then in the general term we had n minus 1, which would just simply be whatever term you're looking at minus 1. The submission for geometric form the formula for the submission of a geometric series is a times 1 minus Rn divided by 1 over R. Okay, so the proof is also included for this one. The proof would look like this. So you need to prove. All right, I actually want you guys to give the proof a try. I'll show you the proof that we did for arithmetic. I'll keep that on the screen. And I want all of you to give it a try. Whether it's wrong, whether it's correct, send me pictures of your attempt. So you have to prove this formula using this all information that we have done so far. And wait, I'll just put both of these simultaneously so that you guys. Okay. This is the proof for arithmetic that we did. This is what we have learned about geometric so far. Use all this information to calculate, to prove the formula. I'm gonna put myself on mute. You guys have 10 minutes to do it. All right. So how many of you have given this a try? Or do you guys need more time? Did you guys give it a try? You hear me? Can you guys hear me?
Yes.
So did you guys give this question a try?
That is similar to the one that we did before, right?
Sorry?
Is it similar to the one that we did before?
I cannot hear you.
Is it similar to the one that we did before?
Yes, that's why I had both the screens simultaneously open. I'll wait another 2-3 minutes, otherwise I'll just go over it myself. All right, so I think none of you gave it a try or didn't understand what to do. I hope it's the second bit and that let me go over it with you guys then. First step is always writing the general sequence, which is a plus ar plus ar square plus ar and minus 1. How many of you did get till here? You guys can just raise your hands.
Miss, we can't see your screen.
Oh, sorry. Yeah. So how many of you did get till here? Like the first step?
Miss, I actually didn't give it a try, so.
Okay, you guys didn't give it a try. All right. So this is the first step. In the second step, since it's a geometric and it's not an arithmetic, so we multiply r with the entire equation. So we get r times Sn equals to ar plus ar square plus ar cube, so on. And then this becomes arn. Then in 3, we subtract 2, which is this, from 1. So Sn minus r times Sn is equals to a minus ar n. So when you subtract it, you simplify it, you'll get to this answer. And Sn and Sn are common in both. So I take Sn common. This gives me 1 minus r. A is common in both. I take out a and I become, 1 minus r power n. And then this becomes Sn a 1 minus rn over 1 minus r. This is how you prove it. It was a little different from the arithmetic one, but I really wanted you guys to give it a try and think about this proof. Anyway, this is how you do it. These are the 4 steps actually, where you make us and the subject. Okay, now there's an example for you guys to solve for geometric. this is simple formula using example. Nothing too complicated, just like the one we did for arithmetic. So they've given you this is going to be the last thing we do for this topic. Then we'll go towards trigonometry. Most and terms. Yes. So these three parts, this question, it is just use whatever we have done for geometry so far and try if you can find the all the answers to all three. So again, take like 10 minutes or 5 minutes or whenever you're done, just message me on the private chat and I'll see.
Miss, can you please go through it? Miss, can you please go through it?
Sure. Let's wait for the others to try it, and then let's wait for 2 minutes. At 2, I'll just go over it. All right. Did any one of you give it a try? All right. So I think none of you did. All right. So I'll just go with it. We know the first 3 terms of so we know that R is equals to U K plus 1 divided by U K, which is equivalent to U K plus 2 divided by U K plus 1. This is what we know because the ratios between any 2 terms are going to be the same. Now we also know first, second, and third term. So our first term is K minus 6. Our second term is K. Our third term is 2K plus 5. So in the first one, we say that k divided by k minus 6 is equivalent to 2k plus 5 divided by k. I cross multiply, becomes k square is equals to 2k plus 5 into k minus 6. Then this becomes k square equals 2k square minus 12k plus 5k minus 30. Guys, just give me 1 minute. Then I put the like terms together. When I do that and solve it, I would get k square is equals to 2k square. Actually, sure. Minus 7k minus 30. And then again, I solve it further to get k square minus 7k minus 30 is equals to 0. So our first part is done. This is done. Second is to find the value of k. Can any one of you put it in the calculator and find the values? Values are 10 and minus 3. So that's part B. Then we have to find R and we have to find the sum. So R is just simply going to be k minus 6. Sorry, k divided by k minus 6. K is 10 divided by 10 minus 6. So we get the answer as 10 by 4 and then 5 by 2. 5 by 2. Which is 2.5. Then we find as n, the formula is a 1 minus r, n divided by 1 minus r. We put the values. So first term is k minus 6, then that means it's 4. 1 minus 2.5 times, this is S10, divided by 1 minus 2.5. The answer that we get is 25400. So this is the entire 3 parts of this solution. I think all of you are quite bored by now. So if you guys want, because I don't like you guys not participating in the class. So if you guys want, you can take a 5 minutes break, go drink water, eat something, and then come back. We'll start with trigonometry then. But I want you guys to participate. When you guys are back, just text that you're back. Take 5 minutes, it's 2:08 until 2:13. You guys have the time to be free. Okay, are you guys back?
Yes, Miss Campbell.
Okay, I hope rest of you guys are back as well. I'll just start with trigonometric identities and then we'll go towards trigonometric rules and other bits. Okay. So there are three trigonometric ratios: sine, cos, and tan. So here we are dealing with a right angle triangle. Where this is the hypotenuse, this is the base, and this is the perpendicular. In regards to the 90-degree angle, perpendicular and base keeps changing according to what angle you are looking at. So if we're looking at the 90-degree angle, then this is the perpendicular or adjacent, and base is the one on the bottom. If we are looking at this is going to be the same case if we are looking at this angle. Then again, this is going to be the perpendicular and this is going to be the base. If you're looking at this angle, then this is going to be the base and this is going to be the perpendicular and your adjacent. This is hypotenuse. So sine theta is perpendicular over hypotenuse. This is base over hypotenuse. And tan is perpendicular over base. So if, for example, you know base and you know this angle and you need to find the perpendicular, then you would use tan ratio and you'll find the perpendicular. So this is tan theta is equals to base over perpendicular. This is sine theta, which is perpendicular hypotenuse, and cos theta, which is base over. So if you need to find either the angle or the side, you use these ratios. These are used exactly like this for sides. And if you need to find the angles, then they're different. So this becomes tan inverse into base, perpendicular over base. And then for sine, it becomes sine inverse over
Miss, what does the P stand for again?
a piece perpendicular. This could also be adjacent. What do you guys call this?
Hypotenuse, adjacent, and opposite.
Okay,
Yeah.
so I'll just use then adjacent. So this is A.
That's fine.
A. Then it's theta cos inverse. That's base over hypotenuse. So this is for angles. This is the formulas for angles, and these are the formulas for sides. What if you guys don't know any angle and you guys only know two sides? What would you use then? no angle, two sides, and you need to find the third side. We use Pythagoras theorem in this case. Pythagoras theorem. Pythagoras theorem is hypotenuse square is equal to base square plus adjacent square. And if I need to find hypotenuse, then it's gonna be under root base square plus adjacent square. So if you know two sides and you don't know any angle, then you use Pythagoras theorem to find the third side. And if you know one angle and one side, you'll use or the tan ratios. And if you know two sides and you need to find the angle, then also you will use tan ratios. Make sense?
Yes, miss.
Assuming that it does, then let's talk about the sine rule and the cosine rule. All right. So one condition for using all of these formulas is that the triangle should be a right angled triangle. If it's not a right angled triangle, then these formulas won't work. So in that case, if it's not a right angled triangle, there are two different rules that we use. The first one is called the sine rule. And the second one is called the cosine rule. Are you guys familiar with any of these? Okay, I see one yes. What about the rest of you? Okay, I'm assuming that the rest of you guys are not familiar with it. So the cosine rule is as follows: a square plus b square minus 2bc cos a. And a, b, c are like this. This is a, this is b, this is c, this length is c, this length is b, and this length is a. So a square plus b square means this length squared plus this length squared minus 2bc minus 2 times the length of AC, which is b, and the length of BA, which is c, times cos a, cos times cos of this angle. That would give you technically give you the other side that is missing. Maybe this side was missing and you didn't know the answer to it, so you can simply find it that way. Right. This is going to be this is going to be A. So if you know one angle and you know the side that is opposite, this is going to be C and this is going to be A. Little mistake in making the. Okay, so let me explain the formula to you now. When you know one angle and you need to find the length of the side that is opposite to that angle, then you use the cosine rule. How does the cosine rule work? Is that you add up the squares of the other two sides that you know, and you subtract this the product of A and B, which are the other two sides you know, you multiply with 2, and the whole thing you multiply with the cos of the angle that you know, and then you get to the answer. For example, let's say here, you know that A is A, let's say, is 35 degrees, small a is 8, and B is 10. So we can C square is equals to 8 square plus 10 square minus 2 times 8 times 10 into cos of 35. I don't know if I would get an answer or math on this because I just came up with this question, but this would become 164 minus 160 times cos 35. What is cos 35? Can any one of you tell me? I don't have the calculator with me. It's 32.93. That's cos 35. I think your calculator might be in radians because the value of cos lies between -1 and 1 only. So cos 35 degrees would be 0.82. 164 minus 160 into 0.82. So this is going to be 164 minus 131.06. 164 131.06. Okay, I think you gave me the entire answer when you were writing 32.94. So then I find the length of C, which is 32.94. Under root 32.94. Can you tell me the answer for under root 32.94?
5.73.
Points.
Miss, it's in 5.73.
5.73, yes. So this is the length of C. So if you don't know one length, but you know the angle that is opposite to it and the other two lengths, you can use the cosine rule to find it. And similar is the case if
Miss,
you
the
know.
cosine rule is sine A by A, sine B by B, and sine C by C, right?
Yeah, that's sine rule. Sine A by A.
That's the sine rule, right?
Yes, that's the sine rule. If I know all three sides and I need to find one angle out of all the angles, I can use the cosine rule to find that angle as well. I'm just going to rearrange the formula such that my cos A comes on one side and the other things come on the other side. So the formula is going to look something like this. Cos A equals to B square minus B square plus C square. Actually, it's going to be plus C square minus A square divided by 2BC. So if you want to find the angle A, you just simply take cos to this side, it becomes cos inverse of B square plus C square minus A square divided by 2BC. And you get to the angle. Now using this formula, this is a question for you guys. This is a very, very easy question. So I hope all of you can get an answer to this. Just have like 3 minutes to solve it. This is 20 degrees. This is 6.5 centimeter. This is 8.4 centimeter. You need to find C. This is C. This is A and this is B. Give this a try.
Miss,
Yes.
is inverse cos B square plus C square minus 2 square by 2 AB. Is that the formula?
That's the formula for finding an angle. The main formula is this. C square equals to
Okay.
A square.
Miss, can you copy the formula down and keep it on the bottom? So
Sure. There you go. There is one step that you missed. Because when you get this answer, there'll be c square is equals to 10.2. You'll have to take an under root and then you'll get to the final answer. Anybody else who solved and got the answer? All right, I'm assuming even if you guys didn't give the answers to me, you did try solving it. Do you guys want me to go over it or should we just move ahead? If there's another question as well, which is about finding the angle. I want you guys to do that one too. This is 5 centimeter. This is 6 centimeter. This is 3 centimeter. This is B, this is A, and this is C. You have to find angle B using the cosine rule. So let's try this one really quickly in like 2 minutes. If you guys are able to solve it, then we move ahead because we'll end in like 10-15 minutes and then I'll leave 5 minutes for you guys to ask questions if you have any regarding what we have studied today. Okay, so x is 29.9. That is correct. Good job. All right. Let's look at the sine rule now. As one of you mentioned earlier, sine rule is sine A over A equals to sine B over B equals to sine C over C. This is used when you're finding sides and when you're finding angles. This is used A over sine A equals B over sine B equals C over sine C. And for example, you have this triangle. You know this angle is 75. You don't know this angle. You know this is B, this is C, this is A. This is 5.5 centimeters. This is 3.9 centimeters, and this is Y centimeters. Now we need to find X and Y both. So we'll use the sine rule to find it. First we say sine C divided by C is equals to sine A divided by A. We replace the values. We write sine 75 divided by C, which is 5.5. And then we say X, like sine X divided by A, which is 3.9. We cross multiply, we solve, and we get sine X. After cross multiplying and then making sine X the subject of the formula, we get 3.9 times sine 75 divided by 5.5. And then the answer we get is 0.685. So then we say X is equals to sine inverse 0.685, and the answer we get is going to be, I think it's going to be around 0.65. So it's going to be around like 43 something. It's going to be, can one of you confirm if it's like 43 or something? Okay, so it's 43.23. Exactly. 43.24. All right. Now that we know this and we know the other angle, we can find angle B, and that angle is going to be 61.8. Now that we know the angle, we simply write sine B divide, because we need to find Y. I was sine C divided by C. We get sine 61.8 divided by Y is equals to sine 75 divided by 5.5. So we cross multiply and we solve, and we get Y as 5.02 centimeters. So this is how you use sine rule in order to find any missing side that you might have or any missing angle that you might have in the question. Again, sine and cosine rule both can be applied to any triangle there is. It's not necessary that the triangle should be a right angled triangle. The last thing we're going to do for this class is the area of the triangle using sine and cosine. So the area of any triangle, if you know one angle and you know two sides, let's say this is, again, let's use this example, BC, this is going to be B, this is going to be, and this is going to be C. Then the formula for the area of the triangle is going to be 1/2 times A times B times sine C. So if you know this angle and you don't know this, neither you know the other two angles, but you do know this, then you can find the area using this formula. So this is a question for you guys to solve. You have to find the area of the triangle. You know, this is 80 degrees. This is 6.4 centimeter. And this is also 6.4 centimeter. This is, let's say, this is A, this is B, and this is C. Try to solve this. Yes, did any one of you try it? get 8.2 centimeters. The area. You have to find the area. The area. No, it's not 8.2 centimeters. You might have found the length of the third side. Yes, the area is going to be 20.2 centimeters square. Good job. I hope rest of you also did try it. So this is where we're going to stop. If you guys have any questions regarding what we did today, you can ask. Otherwise, I'll just stop. All right, I'm assuming you guys don't have any question. So thank you so much for joining in for this session. And I hope you guys have an amazing exam on Thursday. Best of luck for that. Take care. Bye-bye.